Hi, and welcome to Shadetree Mechanic. Well, how many times this happened to you? You're ready to go to work in the morning, you hop in the old buggy and bingo, it doesn't start. You've got a dead battery. Well, this car's got a dead battery. So the logical thing we're going to do is we're going to jump start it. And I'm going to show you how to do that properly so you don't hurt yourself. There's really not much to it, but a lot of times it's not done right. First thing we're going to address is we're going to talk about battery cables. Here we've got a cheap set of battery jumper cables. Probably came from a drugstore. And don't buy these, they're not worth it. The clamps are too light, the wire's too light, they're not flexible, they'll overheat, just a waste of money. Buy some decent cables. You can get a good set of cables for about $20. These have nice heavy clamps on them, heavy wire, they're copper, they'll carry 400 or 500 amps no problem, and that's what you need. Now the first step in jump starting a car is, we've got another car here with a good battery. Make sure the cars don't touch. Okay, the car that has a dead battery, or the battery that's in a low state of charge, is giving off hydrogen gas. Very dangerous. Don't smoke around batteries. There's warnings all over them. Identify first the positive and the negative. Don't rely on just the red and black, because someone may have changed the cable. Look at the positive and negative on both batteries, because we want to hook it up properly. The first step is, we'll go to the car with a good battery, and we'll hook up our red or positive cable to the positive on the good battery. At that point, we'll take the positive cable and hook it on to the one with the dead battery. Okay? Then we take our black cable clamp and we hook it to the vehicle with the good battery to its negative side. And the last connection, and this is important, we'll hook this to a good ground on the dead vehicle, not to the battery, because if you've got the hydrogen gas coming off it, when you hook it up, the last connection is always an arc, and that's where you have a risk of explosion. Now we'll start this vehicle up. Go ahead and start this, please. We'll start up the good vehicle and let the charging system send some electricity to this dead battery to build it up a little bit. Then what we'll do, we'll start this vehicle. Now that we've got this vehicle running, we're going to take the cables off in the reverse order. And just remember the whole time, be careful. Watch yourself around rotating fans and fan belts. Be very careful. Okay? Thank you. We'll get rid of these cables. And as you see, we've got no headlights on, nothing left on inside the car. The next move is to find out, why was this battery dead? Have we got a charging system problem? We have a starting system problem? Stay with Dave and I. We'll be back with more Shadetree Mechanic as we check out the starting and charging system on this vehicle.
Each year, about 80 million lead-acid car batteries are discarded.
Hi, and welcome back to Shadetree Mechanic. What we've got here is a little 86 Monte Carlo. And I know you've seen a lot of these on the road. They sold a bunch of them, and I'm sure some of you viewers at home have got one just like it. Now this little car here has got a problem with the starting or charging system, and we're going to find out why. But first up, let's talk a little bit how a starting system works and what happens when you turn the key. When you turn that key, a myriad of things goes on. The electricity in the battery is transferred to the starter by way of a solenoid or a starter relay, and the starter engages with the engine's flywheel to spin it over. Now the engine's spinning, the distributor is taking the voltage that's applied to the coil and stepped up many times to a high voltage signal sent to the spark plugs to give some good burn time. Then the engine starts to run. And once the engine's running, the belts drive the alternator, and the alternator, of course, supplies electricity back to the battery to replenish it. Basically, that's how the system works. And we're going to go ahead and check this Monte Carlo to find out why we had a dead battery. We possibly have a starter problem or an alternator problem, a battery problem, or a combination of problems. First thing I'm going to do is I'm going to use this little meter right here. This is a little battery voltmeter and load tester. It's a handy little device and tell us a lot about what's going on. Not too expensive, but if you don't have one of these, you can use a simple digital volt ohm meter. And if you're going to do any work around your car, you're going to need to have an ohm meter and a voltmeter. This is a handy thing to have. So we'll take the meter that I like, and we're going to hook this up in the same fashion we hooked up the jumper cables. The positive to the positive on the battery, and the negative to the negative side. And what we're looking at right here is the battery voltage. And you can see this battery is around 12.5 volts, which is pretty low for a 12-volt battery. It should be up around 13.5 volts. Okay? What I'm going to do is start the car and see what our charge system indicates. Now we should be up around 14.5 volts, or in that okay range, but as you can see, we're not. We don't have any output from the alternator because we have less than battery volts right now because we're using some of the battery electricity to run the ignition system. Okay? So we've got to check the charging system. Now some of the things you want to do is we want to check the cables and connections and make sure our ground is good. Also, check the belt. A slipping belt can cause an alternator not to put out. If you can turn this alternator fan, then the alternator won't charge. Everything seems to be right. So we've either got an alternator problem or a voltage regulator problem. In the case of this Monte Carlo, the voltage regulator is built into the alternator, so we're going to have to remove it. The first step in removing the alternator is to disconnect the battery cable. So we'll take us an 8mm wrench here, and we're going to disconnect the positive battery cable. The reason we do that is, if you look at this cable, we have 12 volts going right to the alternator stator feed on this heavy wire, and there's no fuse and there's no disconnect, so we want to get rid of the current. The next thing we're going to do is get ourselves a wrench and sockets, and we're going to remove the alternator. First thing I'm going to do is take the alternator adjusting bolt loose. We'll loosen that up, slide it down, and slack the belt. Next thing I'm going to do is to take the bolt that goes through the bottom of the alternator and mount it to the block and remove that. We'll probably have to move a couple of these hoses out of the way. And now we're going to unplug the wires. We have one set of wires that plugs off the regulator and field circuit, and then we have a wire that's bolted on the back, which is your 12-volt supply to the stator. We'll remove that. And now the alternator should come right off. Okay, we've got this alternator off.
Hello, pal.
Hey, Dave. How you doing?
Good.
Dave's been in Virginia all weekend in a NASCAR race.
Yeah, I threw my back out, I think, in the pits, too.
Oh,
so.
no.
A little slow today, but we'll make it.
And our man Rusty Wallace won?
Yep.
That's great. It was
Sure.
good to have you back.
Good race.
One thing I noticed, taking this alternator off, Dave, we checked it out, and we found out it had a bad regulator, and we're going to take it apart and put a regulator in it, but I've also noticed, now that I've got it off, our bearings are noisy and rough, and we can shake this, which means that needle bearing in the back is probably pretty well worn, and we'll need to replace both bearings. So I'm going to go ahead and take this apart. What's my first move?
First thing you want to do, Sam, is scribe the case. Make sure that you draw a line across there. It's just like that. That way it lets you, when you put it back together, you can bring the halves back in the normal rotation. Otherwise you can get get them crossed up and you can't get the wires hooked up to it properly, or it won't align properly.
While I take this apart, Dave's going to show you a cutaway alternator, explain to you how it works.
This one used to work at one time. Now it doesn't, of course. This is what an alternator really looks like. It's got a rotating mass, and let me turn it up like this so you can see a rotating mass, which you can see right here, and an armature, and that's this area right here. Now when this turns, you got electrical current that flows into the alternator from the battery. As it turns, it creates AC current. Now a car runs off of DC current, 12 volts DC. It won't work off of AC, so we have to convert that to 12 volt DC. That's what this little bridge right here is all about. This is called a rectifier bridge. This will convert the AC current to DC current, which then lets our alternator recharge your battery. Got that apart yet?
Yeah. That rectifier bridge, by the way, is where you see the diodes. Okay, I've got the 4 bolts that hold it. We'll separate this. Okay. And the brushes are going to pop out. We're going to get our brush springs out of here, which I've managed to get tied together. And we see some things. First thing I see is this is the field, and the field rotates. It's called a rotor, which makes it different than a generator. In a generator, the armature rotates. Okay, we've got some burn spots on our slip rings where particularly the rearmost brush has been bouncing. Got a little groove here on the shaft from the bearing being bad in the rear, and the front bearing's also a little noisy. So although we took this apart to put a regulator in it, we see some other things. What else do you see, Dave?
Well, it looks like the needle bearings are a little dry down in there. And also, if everything was okay on this alternator, and all we would have to do is just replace the regulator, which is what this little piece is, we would take this out and just replace the regulator. But since we got bearings that are bad, we've got brushes that need to be replaced, we could get a kit and fix this, couldn't we?
Yes, also, but look at the stator. The stator's a little discolored, which means this alternator's been hot. Now, one of the things that can make an alternator overheat is if you have a stone bone dead battery and you jump start the car, like we did this one this morning, and you use the alternator, if you do this repeatedly, use the alternator to recharge the battery, it'll overheat it because the alternator is not designed to do that. Alternator is designed to keep a fully charged battery full. Think of the battery as a bucket of water. The car uses the water and the car runs off the battery. The alternator's sole job is to replenish that water, but it does it on a basis where it just keeps replenishing it. It's not designed to charge it up. Needing all this, I think the best thing to do for us is to put on a rebuilt alternator.
That's the easiest and probably the quickest way.
But you can buy one of these for about $100. Don't forget to match it all up. We did that already. Make sure all of these things line up. I've got a mounting bracket that I'll stick in here, and I'm ready to put this on.
And while Sam puts that together and puts it back on the car, we're going to take a short break. And when we come back, we're going to talk about starters. We've got a starter problem, so stay tuned to Shadetree Mechanic. What type of car trouble accounts for the majority of emergency road service calls? The answer? Starting system failure. Welcome back to Shadetree Mechanic. Sam's just finished installing the alternator.
Belt's good and tight.
Good. Now we're going to fire up the car and find out exactly how good a job we did. If everything works right, we should get around 14 to 15 volts here on our meter. So let me hook it up. And okay, Sammy, go ahead and start it up. Yeah, looks like we're getting almost 15 volts there. Okay. All right, so looks like we've solved our charging problem. We got almost 15 volts, so the charging system is okay, but this car has another problem. It's got an intermittent starting problem or starter problem. We're going to back the car in the garage, take it off, see if we can find out what's wrong with it. Okay, we got our car up on the lift and we're about ready to take off our starter. Now before we do, we want to disconnect the battery cable. The reason for that is because there is a cable leading from the battery down to the starter. That cable is extremely hot. In other words, it's got a lot of high amperage current in it. So we want to disconnect the battery because if we disconnect that cable off the starter and let it flop around and touch the chassis, it can cause a severe arc. So we've done that. We're ready to start. You ready, Sammy?
I'm ready. Okay, right here we've got our starter motor. And we're going to start by removing this inspection plate. And that's held on by a few 10mm head screws here. And this inspection plate covers the torque converter, the flywheel ring gear. We'll see all that as soon as I remove it.
Is this standard on a lot of cars, Sam?
Yes. You'll find that in just about everything that's on the road. This is a little dust shield or inspection shield it's called. Keeps the trash out of it. Here you go. Hit some screws.
Okay.
And here's our torque converter. And this torque converter is hooked to the flywheel or flex plate, and these are our starter ring gear teeth that the Bendix drive engages with. And if you have that grinding sound, if the Bendix is not the only culprit, you could have worn teeth will roll the flywheel and inspect those.
How those teeth look?
What I see of them looks pretty good. All right, the next thing on this General Motors starter, the bolts go straight up. And we've got these transmission cooler lines in the way, and we can move them a little bit, but be careful not to bend them or deform them. First thing I'll remove is the inside bolt, which is a long bolt. By the way, some of these starters will have a shim at the top. Don't lose the shim. And if you get a replacement starter, it'll come with a shim. Sometimes you have to shim the depth of the pinion to the ring gear. Okay? Now I'm going to loosen the second bolt, which is the short one. I'll turn it back a few rounds. At the front of the starter, I've got a little support that supports the brush end. And I'm going to need another extension and a flex socket. And I believe I've got half-inch flex socket right here.
A collection of flex sockets and extensions is pretty handy when you got to remove these starters.
Yeah, you're going to need a few tools. There's no doubt about it.
Some of these are a lot easier than others. This one isn't one of the easier ones, but it's not all that bad.
Okay, I'm going to put this flex socket up here and turn this support bolt loose. Once I remove this, we'll be able to drop the starter down. Okay, I'll just take the rest of the starter bolt down here the rest of the way. And when I get this bolt down, then the starter's going to drop down into place, okay? And all I'm going to do is have to take these two wires off here and pay attention to where they go, and the starter will come right out. Battery cable off, these two wires off, and our solenoid wire off. And we've got the starter out in our hands, and we're going to take it over to the bench and check it out.
Hey, you got her off, hey, Sam?
Sure did.
Good.
Okay, let me get rid of these safety glasses. First thing I noticed when I got it off was this bolt is a little loose right here. The heavy battery cable connects. That's a voltage drop problem right there. That could cause our intermittent.
What generally goes wrong with these starters, Sam? What's the biggest problem you've run across?
Well, either the solenoid goes bad, so the switch doesn't engage and send the current, which connects the battery cable with the inside of the starter, or you've got an open circuit on the commutator, so the brushes can't get the start of the motor. Okay? What I'm going to do here is remove this solenoid, and we'll take it apart and take a look at it. A couple of screws hold it on, and this little nut driver makes handy work of that. And then we've got a bolt here that connects it to the brushes or the field poles inside. Okay? Pull this off. Once we get the screws out of it, we just rotate it, because there is a lip on it, and we pull it off, and you'll see there's a spring inside the solenoid. Now inside the solenoid we have, the solenoid's a magnetic field, and we have this plunger here that sits in this position. When you twist the key to the start position, the solenoid pulls this winding in. And if you look down here, you'll see what happens. As we pull this winding in, there's a throwout fork that throws the drive pinion and engages it with the flywheel. Okay? So there's two parts to the solenoid. I'll put the starter here for a minute. When you take this thing apart, and you're going to go ahead and you think you may use it over, wrong size wrench here.
Which one do you need here?
Oh, the 9/16. I've got it. I've got it loose. Yeah.
You got the strongest fingers I've ever seen.
Okay, we'll pull this apart, and here's one problem. This bolt right here, which makes contact with the ring inside the solenoid, these are mating surfaces, they get burnt. Now this one isn't burnt too bad, but it was loose, could cause a voltage drop right across this contact, and then you get that intermittent click, click, click. Okay?
That way it won't energize the solenoid as
Right.
much.
So we've got a solenoid apart here. Next thing I'm going to do is pull this starter apart.
Okay, well while he's doing that, we got a starter that's cut apart. And this will give you a little bit better idea of how they work and what they look like. This is the starter motor. It's just an electric motor, but it's a very high torque motor. And this is the solenoid that Sam just took off. The way it works is current flows into the end of the solenoid through this battery connection. When you turn your key, current energizes the solenoid, and when it does, it will force this starter drive forward. This is called a Bendix, they call it, but this is your starter drive. It'll force it forward. When it does, these teeth right here will engage with the ring gear on the flywheel. Once these teeth engage, then the starter spins the engine over, and if everything's working right, the engine should start. Once you let go of the ignition key, in other words, take it off the start position, that'll de-energize the solenoid. This retracts, and you should be home free. This is what your starter is. This is how it works.
Okay,
got her off?
Yeah, first thing I do is I pull the end frame or the brush cover off. And if you look at it, it's just all full of metal. Metal filings, as dry as can be. And here we get a good look at the brushes. And the brushes are worn down to the screws that affix the brushes. And the commutator, which we're going to see when we slide the housing off, okay? And this is the housing with the field poles. These field poles energize and turn the starter. We're looking at the commutator that the brushes run on, and they're smooth. There should be grooves cut there, and they're all packed with the worn brush.
That's had a lot of starts, hasn't it?
It's had a lot of starts. And here we have our shift fork that came out that the solenoid hooks to, and look at the wear on that. This shift fork is worn tremendously right there, so it doesn't get the drive all the way out into the flywheel.
Now, can you get like a kit or something and rebuild these starters, or is it really worth it?
Well, you can get a new fork, a new drive, bushings, but you have to have a growler, because you have to undercut. This is what they call the mica. It's not worth it. What we need to do here,
at home.
what we need to do here is to put a replacement or a remanufactured starter, just like this, complete assembly, ready to go. We'll put it on this car.
Now, what does a remanufactured starter really cost?
A good quality starter like this is probably going to cost somewhere between $100 and $150, and don't forget the box deal.
Right. As we've said in the past, anytime you have a remanufactured product, always save the box it came in and return the old one back in that box.
I'm going to go put this in.
Okay. All right. Well, while he puts that in, we're going to take another short break. When we come back, we're going to show you some new products, so stay tuned. More than 13 million remanufactured alternators and 11 million starters were installed last year in the United States. What you got, Sam?
I got this great little charging system analyzer by Owatonna Tool Company, and it has two leads that you hook up to the battery. Real simple, and by these LEDs here, it'll tell you if you've got an alternator problem, a bad battery, or a bad regulator.
Boy, that simplifies battery testing,
It's
doesn't
about $35, $40, a great little tool.
I like that. Boy, if you're like me and you've ever gone and left your car lights on and drained your battery, what you need is Battery Buddy. It mounts up to your battery and automatically monitors the voltage level. Once it reaches a certain level, it'll shut your battery off. So if you've gone away and left your lights on, you don't run it all the way down. About 60 bucks, it comes from Masco. Quite a handy little tool. Well, that's about all the time we have for today. Remember, if you see anything here you don't feel comfortable with, go see a pro. Until next time, so long from Shadetree Mechanic.
See you later.